Hey everyone, and welcome to today's Explainer. Speaking to you straight from the front lines of AI research, I have to say, we are witnessing a massive, somewhat hidden architectural shift happening right now inside Google DeepMind. We're talking about an ambition that goes way beyond just generating digital text or some pretty images. They are literally building the foundation to simulate the physical reality we live in right inside a virtual space. It's absolutely wild, so let's dive into exactly how they plan to pull this off.
So here is our roadmap for today. We'll start with the ambition behind virtual simulation, look into the true aim of a key Sora developer who recently jumped ship, break down what a world model actually is, explore how this ties into Gemini, and finally, look at the very real impact this is going to have on gaming and our future.
All right, let's jump right into part one, the ambition of virtual simulation.
To put it bluntly, Google's true aim here is achieving artificial general intelligence, or AGI. This is the holy grail of our field. By building generative models that can actually simulate the physical world as a virtual reality, DeepMind is laying the absolutely critical groundwork for AGI. You see, among AI researchers, it's pretty widely understood that giving an AI the ability to truly comprehend the laws of physics, how things actually interact in space, is the necessary breakthrough to spark genuine, human-like general intelligence.
That brings us to Section 2, the Sora developer's true aim and a major talent shift in the industry.
So, a massive indicator of this whole shift is the recent movement of Tim Brooks. If you don't know the name, he was a key leader behind OpenAI's incredible video generation AI, Sora. Well, he left in October to join DeepMind, and honestly, that was a huge industry signal. He isn't just there to tweak code, he is spearheading a brand new project team with a highly ambitious goal. They want to build massive generative models that power visual reasoning, integrate complex agents, and ultimately drive real-time interactive entertainment. They are trying to build the world itself from scratch.
Moving on to Section 3. What exactly is a world model?
As an AI researcher, this is where I need to draw a really crucial distinction for you. What actually separates a slick video generator from a true world model? Well, a world model is not just a digital flipbook or some clever animation trick. It is a system fundamentally designed to replicate how the real world actually works. Think of it less like a video player and more like an intrinsic physics engine running inside a virtual space. It actively processes physical laws, mechanics, and those really complex causal relationships that govern our reality.
To put that into perspective, think about traditional generative models like Sora. They rely heavily on visual reproduction. They can easily generate a super realistic video of someone pitching a baseball because they've seen millions of videos of exactly that. But here's the catch. They completely lack the understanding of the physical mechanisms. They don't actually know why the ball moves. On the flip side, true world models operate entirely differently. They possess causal understanding. They decode and process the underlying physical laws, like gravity, wind resistance, and momentum. That is the massive game-changing leap in this technology.
Meta's chief AI scientist, Yann LeCun, actually hit the nail on the head at the Hudson Forum recently. He described a world model as a mental model used to understand how the world works. It allows a system to imagine a sequence of actions it might take and literally predict how those actions will affect the world around it. But, and this is a big but, building these predictive models is incredibly difficult. It requires an astronomical amount of computational power and highly precise training data. It is quite literally one of the absolute biggest hurdles in all of AI research today.
Okay, Section 4, Gemini and interactive generation. How does this fit into the ecosystem?
DeepMind has a very practical blueprint for taking this mind-bending theoretical research and turning it into everyday applications. Step 1, build that advanced world model. Step 2, and this is where it gets crazy, integrate that model directly into Google's massive large language model, Gemini. The final step is to deploy this as a real-time interactive generation tool. The vision here is that just as effortlessly as we chat with the TechSpot today, we're going to be able to generate and interact with entire virtual worlds that actually obey the laws of physics, all in real time.
To speed this whole thing up, DeepMind is leaning super hard into internal collaborations. They're partnering with the Genie team, who are known for their Sora-like video generation, and the Veo team, who handle existing 3D environment simulations. Their explicit goal here is to expand these world models into interactive video game environments. Now, even Gemini itself will tell you that true real-time interactive 3D simulation is still heavily in the R&D phase, but look, the trajectory we are on is undeniably clear.
Which brings us to our final section, the impact on gaming and our future.
Because, this isn't just theoretical science for some distant decade. The economic shift is already slamming into the video game industry right now. According to CBL Economics, a staggering 86% of game companies have already adopted some form of generative AI tools. Even before these fully realized world models hit the mainstream market, the industry's reliance on AI generation is already heavily cemented.
And this aggressive integration carries a pretty brutal prediction. It's projected that we could see nearly 15% of all jobs in the gaming industry lost by 2026. Think about it. If an AI can inherently understand physics and just generate fully interactive game worlds in real time, this kind of industry disruption is only going to accelerate. So, I want to leave you with a fundamental question to chew on. These technological leaps toward artificial general intelligence are undeniably fascinating. I mean, speaking as an AI researcher, it is absolutely thrilling to watch. But we have to step back and ask ourselves, is it truly beneficial to spend these massive resources, talent, and computational power on modeling a virtual world? Or should we be focusing all that intense effort on improving the physical reality we actually live in? It's a heavy question, but it's one we all need to consider as this technology explodes over the next few years. Thanks for joining me on this explainer, and I'll see you in the next one.